Hello, everyone. This is the Control Up webinar on Logon. We will start in about 2 minutes. We still have quite a few people coming into the webinar, so starting in 2 minutes. Hello, everybody, and welcome to our webinar on Logon research, metrics, and best practices. My name is Bassam, and I am your moderator for this session. First, a couple of administrative items and also some breaking news. We are recording today's session, and it will be available for replay. This session is designed to be very interactive with you. We ask that you engage with us with questions and comments from the beginning and not save the questions till the end. And I will chime into the presentation from time to time with your questions. You can message us by expanding the questions section in your GoToWebinar client and by typing into that box in your GoToWebinar client. If you'd like, feel free to send us a test question now and just to say ping test whatever, and we can verify that we got your message. Keep in mind that there's a slight delay because of the tool and because there are over 529 of you registered for this session, and we may be a bit slow in responding. Now for the piece of news. We just received a text about an hour ago from Steve Elgin, our co-presenter from Omaha Health, saying he unfortunately cannot join today's presentation. This is due to some major issues they had last night, and he said he may try to join in the middle of the session, but we are going to proceed without him. Nonetheless, I am very excited about the session today. We do have all of Steve's material. We have his presentation. We've done several practice sessions, and Eugene is going to be covering Steve's slides today. So you'll get all the content and everything that we had prepared for you. So let me hand the discussion over to Eugene, who will begin with an introduction.
Hello, everyone. I'm Eugene, and we're here today to talk about industry metrics on Logon performance and healthcare IT best practices. As Bassam mentioned, we were meant to present this together with Steve Elgin from One World Community Health Centers. As Bassam mentioned, there are some unforeseen emergencies going on in Steve's environment, so sadly he was unable to join us. I'm perfectly capable of presenting most of the material that we prepared for this. So rest assured that we're going to save all the good content for this presentation, and we're going to show everything that we planned for. Having said that, I think that the customer perspective is really important, and we'll look forward to other opportunities of presenting together with Steve, because his point of view on this subject is really unique, and we'll perhaps do this some other time. But again, for this webinar today, there's a lot of great content for you, which is going to basically be around the global research and the local perspective, what we saw at the customer site. Let's get started by talking a little bit about the motivation that we had for this research. Basically, we started measuring logon duration with ControlUp and analyzing it in the global database with ControlUp Insights. We did this for almost 2 years. And when we started publishing the results and talking about the results, we first encountered a number of motivations and reasons why people are interested in this subject. So why monitor logon duration? This is one thing that we're going to discuss. We're going to talk about establishing a global benchmark. Why is it important to have a global benchmark for something like logon duration? Why should you be worried about logon duration, especially if it's not good? So we're going to start with that, with the global perspective, and then we're going to dive into a specific example, into the One World Community Health Center's example, looking at specific metrics and specific findings, and talking about how basically how logon duration can be improved together with other aspects of user experience. Finally, we're going to survey some best practices and lessons learned from that particular case, and hopefully help everyone implement those takeaways and insights in your environments. Basically, in this webinar, we'll try to use our global findings on logon duration as a backdrop for a real-world case study. And the ultimate goal is to share some practical insights that can help you assess your environments and hopefully improve them with regard to productivity, resource utilization, and user satisfaction. So first of all, why should we care about slow logons? And I'm talking about healthcare IT, and we're going to give a lot of examples that are relevant for healthcare IT, but obviously this is relevant for other industries as well. But why should we care about slow logons? So the first and I guess the very simple reason is because logons, when they're delayed, when they're slow, there's a waste of time associated with them. So the user, when a user is waiting for their desktop or their application to become available, time is wasted. And as our research shows, the average total time spent on logon delays in an organization is about 1,400 hours per year. So an average organization in our sample, which we're going to talk about the sample in a little bit, but on average, that means that about 159 working days are wasted yearly by an average organization in our sample just on waiting for desktops and applications to open. So logon duration constitutes a delay. There's a delay and there's a waste of time of organizational productivity during the time that the users are waiting for their desktops or application to open. Obviously, in the healthcare scenario, those users may be doctors, may be patients, they may be caregivers or other personnel who, upon whom basically the patients depend to receive better care. So when they're waiting, the assumption is that when the user is waiting for something to happen, waiting for the desktop to open or an application and medical records application to open, the assumption is that during that time, nothing productive happens and the user is just waiting. But there is even a worse scenario. So if a user is waiting and nothing happens during that time, then this time is not spent productively, obviously. But a worse scenario is possible if the long delay causes the user to lose focus and forget what they were about to do. So I know this from the IT perspective. Sometimes as an administrator, we log on to a server, we'll wait for the server to initialize, we'll wait for the desktop to become available. And if this process takes too long, sometimes I find myself forgetting what was I about to do on that server. Why did I log in the first place? So especially when the delay is very long, and we'll see that in some cases, in some extreme cases, the delays are very long. When the delays are long, they can break the user's concentration and they can lead to a loss of productivity, which is even worse than just a simple delay. So this is another reason why you should care about logon duration, especially in the extreme cases. Another reason is the underlying misconfigurations that cause the logon duration to be slow. Basically, again, especially in the extreme cases when logon duration is really, really high and the delay is long, if you look in the underlying reasons for that, you basically discover that sometimes some very strange things happen in the environment and some strange configurations are applied, whether by mistake or just something broke. But basically, over time, any IT environment develops all sorts of phenomena that are unwanted, all sorts of misconfigurations. Let me just give you a common real-world example that we're seeing. A user profile misconfiguration that can cause massive amounts of data to be copied from a file share to the Logon profile, to the local profile during logon. So, for example, a large Outlook data file can delay the logon by dozens of minutes if it's large enough, like a 4 gig Outlook data file. I've seen it delay logon by up to 40 minutes. And during that time, when the data file and the profile is getting copied to the server during logon, basically this thing shouldn't happen in the first place. But if it's happening, it's not only wasting time, it's wasting server resources, it's wasting client resources, and it's wasting precious network bandwidth and other resources. And basically, if you look on the extreme cases, and it turns out if you examine those extreme cases and look at the underlying misconfigurations that cause the extreme logon delays, you discover things that shouldn't be happening in your environment to begin with. So this is another independent reason to look into logon duration, and especially in the extreme cases. And another reason is that logon duration is correlated with other UX metrics. So when we talk about user experience, there are other aspects of user experience that also deal with delays. For example, the time it takes to load user applications, all sorts of timeout errors or repeated clicks by the user. All of those constitute bad user experience. So it turns out that the more time users spend waiting for their desktops and published applications to become available, the more time is also spent on other delays in the network. So on other delays in the environment, sometimes it has to do with slower applications, sometimes it has to do with slower websites on the intranet or other systems responding slower. In other words, if your logons are slow, chances are that other things are also slow in the same environment. So it's a good indicator of slowness and bad user experience outside of the login process.
Hey, Eugene, can I interrupt for 1 second?
Sure.
Yeah, so there's a lot of questions that are popping up on how fast is fast, how slow is slow, and I respond to as many as I could, saying that is a key point of the presentation. You'll be getting to that in a few minutes. The other thing I want to mention, and welcome actually, running in last minute, is Steve Elgin. Steve, are you with us here now?
Yes, I am here. I apologize for that.
Welcome, welcome to the webinar.
Hey,
I will let
great
you and you take it from here.
Thanks. So, Steve, we're looking forward to your part, and let me talk a little bit about the background, the global background, the global research, and we'll arrive at the part where we're talking about your environment in just a few minutes from now. And of course, the question about how fast is fast and how slow is slow is a great question, and it's mainly a great question because we spend a lot of time researching this, and we have hopefully some interesting answers for you. So let's talk about the actual research and how we obtained the information. So the research basically is an unprecedented data set. It has about a quarter billion logons from about almost 900 organizations worldwide. We're talking about actual organizations, not small labs. I'm talking about production environments. So this is almost 2 years worth of data, and we're spanning roughly 20 different industries. And there are 132 healthcare organizations in the data set, as you will see. And this makes the findings perhaps a little bit more relevant for the healthcare industry, but not exclusively. We have, as you can see on this slide, we have about 177 million virtual application logons and about 61 million VDI. When I'm saying VDI, in this case, virtual desktop logons. So we'll talk about this distinction a little bit later into this webinar. And basically, what we're hoping to present here is a global perspective, which is obviously going to be messy, and there's going to be a lot of variance and a lot of numbers. But what we're trying to create from those numbers is sort of a baseline, which will serve us as a tool for analyzing local findings. And we're also going to do this during this webinar. So to the bottom line. So when people are looking at large data sets, they're looking for some single number that's going to describe the whole data set, and this number is usually the average. So the average logon that we find in this huge data set, the average logon lasted for just about 20 seconds, as you can see here. So what does this mean? This means this provides some sort of anchor to talk about this huge data set, but it definitely doesn't tell the whole story. For example, a median is sometimes used to sort of enrich the understanding of the data. So an intuitive way to understand the median is by saying that a median of 14 seconds means that half of the population, half of those 250 million logons were finished in under 14 seconds. So that means that if the median is 14 seconds and the average is 20 seconds, that means that there are a lot of extreme results that are much slower that make the average be higher than the median. And we'll talk about, as we progress into the presentation, we'll talk a little bit about the details of this distribution and how it basically plays out when you look at the details. So, but in the global perspective, again, if we're looking for an anchor number, then the flat sum of all of those 250 million logons in the data set, the average is 20 seconds. So this is one key anchor. Now, when we're looking at particular environments, specific environments, an average for that environment is helpful. So if you're looking at your environment and trying to understand what is the average logon duration there, you're basically using a single number to represent the average in the entire environment, and let's call this the organizational average. So if we take all those almost 900 organizations in the sample, and we take all their averages and take an average of those averages, then the average, the grand average is about 27 seconds. That means that on average, an organization has an average logon duration of 27 seconds. That also provides some kind of anchor if you want to sort of assess really quickly if the situation in your environment is really bad, or is it okay, or is it really good, then this 27 seconds can be used as a sort of anchor. When we're looking at different industries, we actually saw that healthcare organizations tend to be in a little bit of a better shape than the general population, and healthcare organizations actually have a little bit of a higher standard. So an average of 20 seconds organizational average for healthcare organizations in this sample. So a couple of more words about the global distribution, and then we'll talk about Steve's environment and dive into specifics of findings of how this may play out in a specific environment. So one thing that I want to mention is another dimension, which is not only the speed of the logon, but also the consistency of the logons, or the variance. So as you can see on the right, we have here a chart that presents basically those two dimensions together, the consistency and the average logon duration. So just for sake of clarity, let's take a couple of examples. So this organization right here, by the way, the size of the bubbles represents the number of logons per day. So in a way, it represents the size of the organization. So this organization here, of average size for this sample, has about 11,000 logons per day. And we can see that their logon duration, which is on this y-axis, is about 6 seconds. So it's pretty It's pretty fast given the distribution. But it's not only that the average logon duration is fast, it's also very consistent. So we measure consistency by the standard deviation or the variance. So the standard deviation of this particular organization is really, really low. That means that they're in the green area. That means that they have both fast logons and very consistent and predictably fast logons. So a user logging on to this environment basically can count on an environment which is fast to initialize and pretty consistent and predictable, which is not less important when we're talking about user experience.
Eugene, let me come in with a couple of questions that we should probably answer pretty quickly, and they're important questions.
Sure.
When does the clock start? How do you know when the login starts and when login ends? So that's the first question. The second one is this for admin logins? Admin logons tend to be faster than regular user logons. And that's primarily it for now. Okay,
so from as far as we're concerned, the login starts when the user ends entering their credentials. So basically, from the user's perspective, when they are done typing the username and password and click OK or hit Enter, that's when we start measuring. Because when user is still typing, that's the delays are really on the user and not on the system. But once the user confirms the credentials and commits them and it starts waiting, then that's when we start the timer basically for logon duration. When the logon duration timer ends, from our perspective, that depends on the type of logon. So as we'll see in this presentation a little bit later, there are two types of logons in this sample. One is published application and another is published desktops. So there's a little bit of a difference when we stop the clock in those two cases. Let's bear with us a little bit longer, and we'll talk about this in more detail. So the point we were trying to make here is that it's important that the logons are consistently fast, in addition to being fast on average. And also, when logons are really slow, they can be consistently slow, but they can also be slow and inconsistent, like in this case. So basically, those two things are important to consider when you're looking at averages. And sorry, Bassam, the second question you asked?
So that was pretty much it. So when does the clock start? And is this for an admin logon or non-admin?
Oh, sorry. Yeah, sure. The admin logon. So here we're looking at entire population of production environments. So the assumption is that admin logons are a really, really small share of that. And of course, this can be checked and this can be sanitized. But when we're looking at the entire this entire huge sample, it's safe to assume that admin logons are a really, really small share, and even if they're significantly different from end user logons, this should cancel out in terms of the averages, because there's just so much more logons from the end users. So the answer is we don't separate those admin logons, but they really constitute a very, very small fraction of this data set. So on the global perspective, you have, hopefully we provided you with some very, very rough guidelines, and we'll come back to the global stats a little bit later. But for now, let me turn this over to Steve, who will tell us a bit about his environment and share some of his experience on battling slow logons in the real world. So I'm going to continue driving the presentation. So Steve, just go ahead and tell me when you want me to advance to the next slide.
Okay, sure. Well, hello everyone. Steve Elgin here, IT Director for One World Community Health Centers and Heartland Community Health Network. I apologize for my tardiness today. There's never a dull moment in IT, and we just had an issue about an hour before this started, and so we got it cleared just in time for me to get on this webinar today. So appreciate everyone's flexibility. So I'll talk a little bit about my environment that we have for One World Community Health Centers. We're currently running XenApp, publishing applications and published desktops. There's no VDI in our environment today. About 275 peak users at a given time throughout the day. It's virtualized. It was virtualized on VMware with HP servers, AMD processors, and we've been running that for a few years, and was having a real issue with consistency of logon performance and user experience in general in the environment, and we were just having sort of a tough time getting our head wrapped around, okay, what are the decisions that we have to make in order to improve this user experience? And so late in the fall last year, we made an investment in Control Up and immediately started to see where the problem was. And so we'll get into that in just a little bit. If you want to advance to the next slide for me there. And so you can see about on an average day of roughly 405 users are connecting into the environment. We're running concurrent licensing, and so like I said, a max about 275 or so users, 2,600 sessions a week. And you can see in this screenshot here that there's some examples of some pretty atrocious logon times, 192 seconds, and we've seen some that have been much higher than that in the 300s and 400s. And so what would happen is, obviously, as you can expect, first batch of users that start logging on in the beginning of the day are getting pretty reasonable logon times. As you kind of get to that sort of critical mass where you're getting peak users in your environment, any subsequent logins begin to suffer, and that was something that we were noticing throughout the day, and so that's where some of these numbers come from. So you want to go to the next slide for me, please? So this is a snapshot of basically 1 month, and so late fall timeframe last year, just to kind of put things in perspective, we made the investment in Control Up. We started to be able to correlate metrics between the hypervisor, the VMs, the storage, the networking side of things, and correlate that with logon times and user experience. And one of the things that we were realizing that we were not aware of before is we were having a problem with CPU ready in our environment, and so that was contributing to a poor user experience. And we were not really aware of that leading up to this, and so we started really kind of diving in and trying to understand, okay, what does it mean to have this problem? How do we address it? And what we learned in that process is we had sort of a two-part issue. One was we had a VM sizing issue. We were running smaller XenApp servers with 2 processors and multiples of those, and so then we landed on VMs that had 6 processors with more RAM memory, so we could put more users on there. We were also running into an issue with vCPU overcommit, and so in some cases it was 2x, and so we changed our VM sizing so that everything was 1-to-1 vCPU to pCPU, and then also tweaked our sizing of our VMs a little bit, and we started to see our logon performance improve a bit, but we realized it could still be better, and so we began in February to put some new hardware in. We switched away from AMD procs to Intel processors. We switched hypervisors to Zen server because we're using PBS, and we wanted to take advantage of PBS Accelerator and just some of the other integrations there, as well as save some additional costs because we had entitlement to Zen server for our environment. And so really, we don't have a long snapshot of data where the Zen server is really that environment, the Intel environment running on Zen server is where all our users are at, but really starting about March 6th is when we start to put users on there. And so March 6th, we've got basically everybody of our environment is now going into that new environment on new hardware that's been sized appropriately. It's using local SSD for storage, PBS Accelerator, and we didn't make any VM changes in terms of tuning the actual VM itself. This is just back-end hardware stuff. So now what we're starting to see over the last few business days is we're averaging around 13 seconds for logon duration as measured by control up. And so it's pretty significant savings going from, you look there in February, we had a day we're at 27, probably averaging around 23 or 24. And you can start to see that decline in logon duration just by making some sizing adjustments. Next slide, please. So this just sort of shows January, March, February. You can see we're right around 27 seconds average logon time in January. Some of the adjustments we had made with our AMD environment, with right-sizing VMs, and oversubscription on our vCPU reduced that a little bit, not significantly enough though. And then you can see March, it's gone down even more. If we were to refresh that particular slide and look at more recent data, you'd see that it's closer to the 13 to 15 second mark. And so what we're expecting is as time goes on, that's going to continue to go down. And what we're noticing is that this newer, better hardware was obviously very needed, and we're getting faster and more consistent logons to the point like when we're at peak load now with all 275 users on there, we're not really seeing any logons that are exceeding 30 seconds, which is really great for our users and our user experience. So next slide, please. So this is just a screenshot of Director, and which is a common tool that folks may use to look at trending for their login times. And so I just wanted to sort of show how Director was measuring the login times and what the differences we were starting to see. And so the peak of that graph, the orange line, is kind of a point in February where we were at our worst possible configuration in terms of VM sizing, oversubscription. And then the blue line indicates where we were at when we started getting users on Zen server. And so it's a pretty significant decrease in login time comparing those 2 days. And so I think it's important to kind of acknowledge that Control Up does measure logon time differently than the product like Director does. But even in Director, we're starting to see some improvements with logon time, and it's more in the range of 20 to 30 seconds improvement, which has been great for our users as well. So next slide. So here's a couple of screenshots. This is something from November of last year. You can tell that we have an obvious issue with CPU ready and CPU excessive SMP use. The VMs are under stress. This is just a portion of the VMs that we were running at the time. The average logon duration actually doesn't look that bad, but when you go look at the sessions view, you would see the sessions that are taking 300 and 400 seconds to launch, which was pretty terrible. And so then just using their applications in that VM once they're in there, the experience was really bad because those processes were just waiting on physical processor to become available to process whatever the user's operating at that time. So next slide. So this is the same hardware, the AMD hardware, HP hardware. After we had sized things properly, you can see we have more than double the amount of users on there. Logon duration still relatively similar in some respects, maybe not even worse. CPU usage was always much higher than what we had before. As you can see, it's 50% or more of the CPU in a lot of cases is pretty much being consumed, and that's what it looked like across all of our VMs. And so we were starting to address part of the problem, but we realized there was still more work to be done. And so that's when we decided to buy new hardware. So we'll go to the next slide. Okay, so here's on new hardware. Much better logon times on average. Health of the VM, the stress level looks much better. Not quite as many users on those VMs because we spun up more virtual servers in this particular configuration. the thing that we kind of learned in this process, and I do have to shout out to, a lot of this wouldn't have been possible if I didn't have good people in the community that were engaged, that I was networking with. Some of them are fellow Citrix CTAs, such as Scott Osborne and DJ Eshelman, who were people who were working with me, and I was able to kind of bounce ideas off of on how I might start to address some of this stuff. And so I just want to throw that out as sort of it's an important acknowledgement that me and my team, we didn't just do this alone. We really were able to leverage folks in the community to help us learn from what other people are doing. And so this is a product of engaging in that community, which was really helpful. So next slide. Unless that's everything.
Hey, Steve, while the slide's coming up, I do have a couple of questions for you. Maybe you can answer quickly. Sure. What version of Zen app are you using? And then that's more detailed question.
So we're a Zen app 7.15 cumulative update 1. Our session host servers are 2012 R2.
Okay. CPU overcommit question. When you said 1 second to, when you said 1-to-1, are you stating that you would not provision more than one vCPU on a host than physical cores on the host?
Correct. So the hosts that we were running were HP DL385s. The AMD processors that are in them, 2 sockets combined had 24 physical cores. Those don't have hyperthreading, and so we were limited at 24 physical cores, and so we allocated 24 virtual cores on that hardware in order to address some of the CPU-ready problems that we were having.
Great. So let me just pick up on the global perspective in a second, but I wanted to point out a couple of things on the previous slides on basically on the screenshots that you see from Control Up. So there's a couple of metrics here. I hope that Steve mentioned them, and I hope everyone is familiar with them, but just to describe in really quickly those metrics. So CPU ready is basically the amount of time or the percentage of time that the machine is waiting for CPU, that the virtual machine is waiting for CPU. And CPU excessive SMP use is actually a result of configuring multiple virtual processors for a VM, and the result of that machine waiting for all of those processors to become available. So this has been described multiple times in the context of planning a virtualization environment, but basically high numbers here may indicate that you actually over-provisioned or you put too many virtual CPUs and the machine is waiting for all of those virtual CPUs to become available from the hypervisor standpoint. And what I like about this screenshot or this series of screenshots is that they're actually showing the hypervisor perspective next to the end user perspective. So you see in the same screen sort of the average logon duration on those machines from the end user perspective together in real time with the hypervisor metrics, which are so important to consider. But the power of those two things combined, when you're able to see those two things combined in real time, I think that's one of the major enablers that monitoring your environment with Controller provides. So I'd like to go back a little bit to the global perspective, and we're looking at our research and our huge sample of global logons. Basically, you can see here on the left that we're basically showing in the left chart the averages from all industries, and you can see that 11% of organizations have an average logon duration of 10 seconds or less, so that's the leftmost bar here. So that means that their organizational average is less than 10 seconds, which I think we can all argue is pretty good. And if you look at the right-hand side, this is only healthcare organizations. You can see that about 27%, so a quarter of all healthcare organizations in the sample actually have an average logon duration of under 10 seconds. So like I mentioned before, the healthcare industry has a little bit of a higher bar set for user experience, and that's great. But this slide sort of puts it into perspective in terms of creating realistic expectations and goals for improvement. So if you know your organizational average logon duration and you want to improve it, it sort of provides you with the global picture that shows how are things normally in the different organizations. And basically, you can see, for example, that perhaps surprisingly, but 5% of organizations in the global sample have an average logon duration of over a minute, which is, we can also all agree, I guess, that this is really slow. And if you're thinking about it, the average, if an average is a minute, so probably the extreme values are even worse. So this is sort of to put this into perspective of what is slow and what is fast. And there's another caveat to interpreting this data, which is the distinction between published apps and published desktops. So, and this is also relevant for Steve's environment, which is going to mention in a bit. But from the global perspective, if we're talking about this distinction, we are seeing, basically we saw 177 million published application logons. So a published application logon basically ends when Citrix or your application delivery mechanism of choice hands over control to the actual published application. So if you're publishing a medical records application, for example, then when that process for the medical records application starts, that's when we consider the logon complete. That's in the published application logon case. And for desktop logons, we're actually waiting for the desktop to initialize, which can be really tricky, and we worked a lot on this. And I can say proudly that we actually nailed a pretty accurate way of recognizing when the desktop is actually initialized. And we're doing this by checking the status of the start menu button. So if there's a whole desktop presented to you and the start menu button is clickable, which is sort of from the user perspective, we believe that this is what a typical user might do. They might click the start button just to see that something is responding. And this is from controller's perspective, that's when the desktop logon is complete. So that sort of explains the difference that you're seeing here. So the average of published application logon is about 16 seconds, and an average desktop logon is about 31 seconds. And the median, the difference is also expressed in the standard deviation as well. In short, when you're looking for faster logons, of course, by definition, published applications are going to load faster than a desktop. So when speed is critical, those two logon types can have very different results and can show very different measurements. So this is from the global perspective. Now, Steve, in your environment, we also have basically an example of published applications and published logons. Can you talk a little bit about the mix of the two and those stats that we're seeing?
Sorry, I had my mic muted. The first one is NextGen, which is our medical record application. And you'll kind of notice there about a little over halfway through the top bar graph that the number of sessions, logons per day are increasing, but subtly the logon duration is decreasing. And that's right around the time when we're starting to nail a recipe on our old hardware where the right sizing of the VM is best for what we had for hardware and the CPU overcommit. And so we're able to ramp up number of logons per day, slightly decrease average logon duration, and our users are not really feeling it terribly. And then the second part is the hosted desktops, and so we're kind of breaking out those two pieces, and you're going to see that same sort of correlation there, where it's subtly decreasing the logon time. And so for our EHR application, you can see the average logon duration was 9.04 seconds. And for the published desktop, it was 37 seconds. And those are pretty close to what the actual user would feel when logging on average.
Great. So to me, seeing those numbers, and we have a different perspective. So this is another perspective on the same. So basically, here we're partitioning the same picture, the same logons, but partitioned into fast, moderate, and slow. And as you can see, the criteria for fast, moderate, and slow for this distinction is slightly different between published apps and hosted desktops. This is, of course, just a arbitrary choice, but it's an educated guess based on what we're seeing in the global sample. Again, to me, the impressive part about the change that happened in Steve's environment is that while the user load doubled or almost tripled in the case of the published app, the logon duration actually declined, actually went down, and the logons became faster. And just the fact that an environment's user experience does not deteriorate when you double or triple the number of users, that means that you have a well-sized and well-planned environment. And we can see here that once the user population increases, the share of fast logons, the blue bars, so the share of fast logons actually grows and doesn't decline. So this to me is a very compelling evidence that an environment is well planned, well sized, and also handles the user load correctly.
Okay, so let me come in with there's actually a bunch of questions, but I'm going to filter the ones out for Steve. Steve, a couple for you. Are you using a memory accelerator on your hosts?
Yeah, so on Zen server, we're using the PVS accelerator piece, and we're using that in DOM0 memory.
Okay. Why was your logon time dropping before you put in the new hardware?
Because it was a kind of a series of different things that we were learning and experimenting with all at the same time, where we finally had this product, which is Control Up, that helps give us immense insight into what's happening in our environment. And so we immediately start tuning and tweaking and playing around with different things just to see how that affects our user experience and what it looks like on the dashboard from a metrics perspective. And so the reason why you're seeing that is because we're starting to get that right sizing recipe correct, where we're sort of balancing scale out versus scale up in the size of our VMs, plus the overcommit ratio of our physical hosts. And so one of the things that it's been a learning process for us. I'm not an architect. I don't staff any architects in my environment on my team, and so we kind of just end up learning a lot. And so this was sort of our first experience in really trying to understand things like right sizing, which so many folks are probably, it's their second nature. And so we're just really diving into that and understanding it and starting to make changes to see how that moves the needle in terms of user experience and the performance metrics that are measured by Control Up. Because prior to Control Up, we were just sort of guessing. We would spend hours and hours trying to tune our gold image, thinking that was the issue, only to realize actually that we had a sizing issue. And it wasn't until we were able to correlate VM metrics, hypervisor metrics, storage metrics on one dashboard, along with user experience, to actually start to really see the picture of where our problem is. Hopefully
okay, one last question for you. CPU excessive SMP use is for ESXi. Is there one for Zen server?
I'd have to go back and take a look at that screenshot here for the.
Let's probably continue on.
I can answer that, I guess. So not to the best of my knowledge. So CPU ready and CPU excessive SMP are VMware specific metrics. There is nothing that I'm aware of on the Zen server front, but I've saw some great minds from the Citrix side of things in the attendee list. So hopefully someone can correct me if I'm wrong here. So one thing that really caught me when what Steve said is that the amount of guesswork involved when measuring things like logon duration or user experience in general. So when I talk to experts and well-established industry experts on this. Many of them say that over the years there's been no real concrete data on logon duration or user experience in the general sense, and there was a lot of guesswork involved. And finally, one of the things that we're hoping to improve in the world is the amount of concrete global benchmarks, and this hopefully this global data set helps a little bit with this. There's an interesting question asked here in the questions pane, and I wanted to direct this to Steve. So have the users actually noticed? Did you get any feedback from the users on the improvement of performance? Have you gotten any feedback from your actual end users on this process?
I wish that I lived in a world where users were really good about giving feedback when things were awesome and better. Oftentimes, the feedback we get are things like, well, it's just slow, or, it's taking forever, or whatever, I do have one specific user who I was working with pretty closely. She's a clinical pharmacist, and she was pretty vocal about the Logon performance for her session. It was very consistently, and I think it's just because of the time of the day that she came in, because it wasn't a GPO issue, it wasn't a Logon script issue, or those other things that you might think that might be specific to a certain user. I think it was the time of day she was coming in during peak times, and her Logon duration was oftentimes in the 60 to 80 seconds time frame. We even saw some that were over 300 seconds. And so now I went and pulled some metrics actually last night just for her specific user account, just to see what it's looked like in the last few business days. And she's right in that sub 15-second logon duration for all of her logons in the last few business days since we moved all of our users to XenServer, and so and got on that newer hardware. So
lack of negative feedback is also good sometimes.
Yeah, it is a good thing.
Yeah, but look, listening to actual feedback from users, and actually this is sort of leads us to start summarizing what we saw here. And I think one of the key notes is and one of the key tips that I hope that Steve can agree with, that is that you should monitor in real time and analyze trends over time. And it's especially important to look at the actual numbers and check the numbers yourself, and look at the actual user experience feedback. And even starting with a stopwatch and looking at an actual logon and sitting with the stopwatch and validating how long does it actually take, even before you have specialized tools like ControlUp to measure logon duration, even starting with the stopwatch or with some feedback from your end users and looking at the actual numbers is a good step. It's a good first step to starting to assess the situation. And the second tip, or the second direction I think that is important to consider, is correlating the user experience metrics, for example, logon duration, application load time, and other things that are related to the user's experience, correlating them with the actual infrastructure and with resource utilization. If you can get to a point where you have a single pane of glass which shows you those hypervisor metrics and the user experience metrics in the same pane of glass, that's ideal, because especially in real time, when you're seeing a decline in hardware utilization or resource utilization metrics, and in the same time you see a decline in the user experience metrics, that's when you can make your most priceless decisions, I guess, with respect to planning the environment. And I think Steve, you can probably relate to that, right?
Absolutely. One thing I'll add to, we're looking at some of the previous charts. It was 27 seconds was the average logon duration that we were seeing, and now we're right around the 13 to 14 second time frame. In our world, in the healthcare world, one of the things that we do when we're trying to calculate ROI and savings is we use 2.1 cents a second for a doctor's time. And so how can we save them time? And so if we look at that cost and look at roughly 14 seconds is what we saved on average, and we say a doctor has 2 logons per day, they have 260 working days in a year roughly, and on our staff we have 61 doctors. That equates to just under $10,000 a year in time that we saved. And then if we measure that in patients, that's about 1 extra patient that they get to see per 40 days, because we're saving them about 30 seconds a day, or roughly 6.5 patients more per year per doctor. So it's not hard savings that we're getting, but when we're trying to equate efficiency and time spent, those are some of the ways that we look at this. And I think those are pretty powerful things to consider when you're trying to calculate your ROI in your organization.
Absolutely, and for some of those numbers actually found their way into the full research, which you have a link here that you can type in and just download from our website. The full research, which has some details on savings that can be achieved when the logon duration is actually cut down. So the dollar value or the cent value per second that you're using might vary from place to place, but I think we can all agree that time is money, and in this specific case of a major waste of resources and a major waste can be prevented by cutting down on delays associated with Logon. So adjusting virtual hardware allocation, I think Steve presented a couple of examples on how virtual hardware allocation can help, or planning or resizing the VMs can help, but also the physical hardware shouldn't be forgotten. Like Steve mentioned, that sometimes just playing with the virtual CPU allocation and memory allocation for the VMs will not solve the issue until you look into the actual underlying hardware, the physical one. From my side, I think one more important thing to add is to set realistic goals for improvement. So, and starting from the most extreme examples is a good tip. So when you're looking at the entire environment, try looking at the slowest logons that you have, or sometimes you can start with the noisiest users, whatever works for you. But if we look at the most extreme examples, usually it's those are good places to start, because that's where you discover the most horrible misconfigurations or the most extreme cases, which are easier sometimes to solve. When you're looking for a realistic goal, I think our research provides hopefully a little bit of a guidance or a little bit of a guideline on how to plan your improvement and what you can work towards when you're looking to improve user experience and logon duration in your environment. So, Bassam, I think we should maybe take a couple more questions. And
let's take a couple more quick questions. We have so many backlog of questions. What was the most challenging part of your trying to right size, Steve?
I think for me and my team, it was really trying to understand how NUMA sizing worked and getting the sizing recipe right for that. And so, for instance, our hardware was AMD processors, they're 12-core sockets. But what we learned, we didn't know this initially, but we learned it in this process, is that it's actually 2 6-core processors on one chip to give us those 12 cores. And so our NUMA size, we had 2 NUMA nodes per socket, and we had to have our VMs sized, something that was divisible into 6. And so we tried 2-core VMs, 3-core VMs, and 6-core VMs, and it turns out 6-core was really the best way to go for our hardware and our workload. The other part that's challenging is just like, you can do something on paper, but you don't really know until you put your actual user load on there. And so, it was a bit painful for our users on some days when we were experimenting with different sizes, trying to see what was going to work best for us.
Well, one last question before we end. How did ControlUp help you identify that these were your bottlenecks?
Sure. So we had next to no visibility in our environment before this, we were using System Center Operations Manager, but it really wasn't painting the picture visually about what we're actually experiencing. And so, honestly, it was the dashboard, the live dashboard view that gave us the most information. And we were bringing in VM metrics, user experience metrics, hypervisor metrics, all into one view. And we could really just sort of correlate everything across the whole infrastructure and see where the bottlenecks and the problems were. And that's how it helped.
Great. Well, thanks to everybody. Big thank you to everybody for attending the session. Hopefully you found it useful. If you did, please let your colleagues know that the session is available for replay if they wanted to see it. And again, thank you very much and have a very productive rest of your day. Bye-bye.
Thank you.
Thanks, guys.